So hi all, welcome to back to malware analysis. I am Jay Lavanya, assistant professor of CS department. So today in this video, we are gonna discuss on the topic called code injection. So how to detect and how to prevent this kind of code injections. Okay, so let's dive into the topic. So first of all, what is meant by code injection? So code injection is a security vulnerability that allows an attacker to introduce the malicious code into the program's execution flow. So it often bypasses by means of existing security mechanisms. This type of malware attack occurs when an application improperly handles some unstructured data, enables the attackers to alter its intended execution. Okay, so these type of consequences of the code injection attacks can be severe, ranging from unauthorized data access to complete the system compromise and data leakage. They can exploit a range of systems including web applications, desktop software, and enterprise level services. So preventing and protecting against injection flaws requires vigilance, continuous code review, and runtime protection for the production systems. Okay, and these kind of such vulnerabilities often arise from neglecting to sanitize some input data properly or failing to validate some output information, especially in some web applications where the data may be directly sent from clients to the servers, right? So this injection attacks exploit this oversight by introducing some code that the application inadvertently executes. Okay, so this is the main code injection, and these are the common code injection methods. So the first one, DLL injection; second one, process hallowing; third one, APC injection; fourth one, reflective DLL injection; and last one, thread execution hijacking. So what is meant by DLL injection? So how it works, like forcing some processes to load a malicious DLL, and how to detect. So looking for some unexpected DLL in process memory or the process explorer. The second one, to monitor, to create remote thread and load the library calls or by using the prop monitoring. That is process monitoring. So we have discussed already in the last video. And check for some write process memory, that is followed by some thread creation and process following, second one. And this, how it works is that creating a suspended persons or process, replacing its memory, and deduction, and looking for the process in suspended state with mismatched memory contents, and check for some empty unmapped view of section, that is followed by some memory reads, and verify the process image on disk versus in memory. And third one, APC injection. So how it works by using some asynchronous procedure calls to queue the malicious code, and deduction to monitor the queue user APC calls, targeting some unexpected threads or look for some thread execution in processes that should not be have some APC. Okay, that is asynchronous procedure call. So that is APC. And reflective DLL injection. So here loading a DLL directly from a memory without using some load library, and deduction. So look for some unusual memory allocation pattern or detect the processes executing code from non-image memory regions. And third one, check for the absence of normal DLL load events. And fifth one, thread execution hijacking. So how it works here is that redirecting some existing thread execution to the malicious code, and for deduction, uh, it will be monitoring some set thread context points, modifying the EIP or RIP, okay, and looking for some thread execution flow changes. Okay, We are going to discuss is about detection tools and techniques. First one, process monitor, that is called as prop one. The filters to use is that operation which is a create thread, operation that is a load image, operation that is a write process memory, and operation that is set thread context. And how to analyze. Coordinate the thread creation with the process activity, looking for some writes to process memory, followed by thread execution. And second one, process explorer. So here the process explorer, it will be verifying the DLL loaded in each process and check for the unsigned or suspicious DLL and examine the thread stacks for some unusual activity and compare the process memory to the disk image. Okay. And this API monitoring tools, it also like virtual allocation execution. It sure sometimes process a memory or create some remote thread sequence, right? And by using some queue user APC or empty create thread X, okay. And next one like we'll be setting the thread context and memory analysis. Like we'll be using tools like a volatility framework and recall and then win DBG, okay. And it also looks for some executable memory regions which is not backed by files or the memory pages with both write and execute permissions and injected code artifacts. And last one, the behavior indicators. So it checks for some suspicious pattern based on the process spawning children, then exiting, legitimate processes making some network connections, or processes accessing some unusual registry keys or files, and processes with some unexpected memory protection flags. Okay, so this is how it will be detecting the code injection technique. So next is that prevention recommendation. So here it enables the attack surface reduction rules in Windows Defender. And second one, by using some process mitigation policies, example, block the remote images or disable the dynamic code. Third one, implement the code integrity policies. Fourth one, restrict the process permissions. That is the principle of least privilege. And fifth one, monitor for some suspicious API sequences in the critical processes. Okay, so this is how you can able to prevent the recommendations. Uh, So this is a like one small example, like code injection attack in wireless based IoT, that is Internet of Things. So here there will be some attacker who's writing a code. Uh, he writes the code in the malicious program. I mean the program where you can to inject some code and injecting the malicious code into the software, which creates a vulnerable software, and thereby the malicious code may be executed, right? Like in IoT device, if you implementing the code, for example, it has to be alarm at 10:45 in the sense he can able to set the alarm at 10:25, right? So at 10:25, for they can do the hall or whatever the organization. So something like that, they can able to inject. And the main common thing, like there is a one real-time example of this code injection attack where it happened. Okay, so there are so many types of injection methods which is occurred, all around the world. So the first thing is that why we are going for these kind of issues, right? And the common mistakes, common attacks, why they are going for these kind of practices. So if you're avoiding some these kind of techniques or whatever maybe, so you can go through it, right? And next one, detection mechanisms for code injection attack. And before going through this, I'll just say what are the advanced detection techniques out there. So first one, ETW, that is event tracing for Windows monitoring, and that is nothing but capture the kernel level events for the process and thread activity, and monitor the image load events. And third one, track the cross-process memory operations. And second one, kernel callback. Use some PS set load image notify routine to monitor the DLL loads and implement the process of the thread creation, callbacks, and third one, hardware breakpoints, and detect the memory modification in the critical processes and monitor the changes to thread context. And last one, Yara scanning. So Yara we have already discussed in the previous video. You can just check out the videos and scan the process memory for known malicious pattern or create the signature for some common injection techniques. Okay, so these are the deduction mechanisms for the code injection. So first one, static analysis, second one, dynamic analysis, and third one, we're using runtime protection. Last one, input validation. Okay, we will see what is so why we are going for these kind of deduction mechanisms before that. So these kind of deduction code injection attack is essential to reduce its effort to find some code injection vulnerabilities. Organizations must take a layer approach, fundamental to which will be the mix of automated tools and manual review. So first one, static analysis. So static analysis tools analyze the source code to identify the insecure coding practices and potential injection points before deployment of the application. So these tools check the code for hard-coded secrets and entry points for some various vulnerabilities like unsanitized user imports or other incorrect handling of database queries. And static analysis identifies issues early in the development cycle, so which reduces the attack surface. So static analysis it is a good approach for catching some vulnerabilities during the development, but needs some frequent update of its vulnerability database or the queries so that it detects the latest vulnerabilities. And next one, integration into CI/CD pipeline for some continuous scanning is another advantage, right? By using these kind of static analysis. And second one, a dynamic analysis. So this dynamic analysis tools perform real test against an application in real time and replicating real world attacks to find the vulnerabilities. Or static analysis is limited for looking some known patterns only, will often miss applications of specific vulnerabilities that may only be found through some applications testing such as misconfigured servers, right? So they may be engaged with the application to some degree so that they are useful for discovering code injection vulnerabilities. And dynamic analysis is complementary to static analysis and concentrates on runtime behavior. On the other hand, it demands resources and expertise to cover all aspects of a real world conditions in a more realistic manner, which takes some time and effort to account for all possible edge cases. And third one, that is runtime protection. So this runtime application self-protection, that is RASP solutions, watch an application's behavior in real time to identify and stop the suspicious activities. So these systems can detect the code violation in real time by looking at patterns like an unfamiliar structure of a query or suspicious system commands. And RASP introduces a layer of security inside the app itself, thereby eliminating dependence on some external monitoring system. And RASP is especially helpful in some production environments where there is an immediate need to react to the live threats. Its adaptability to changing threats makes it a cornerstone of contemporary defensive strategies. Okay, and last one of the uh, most but effective mechanisms to detect is that strict input validation. Okay, so this strict input validation determines what kind of input should look like. For example, a hexadecimal or a longer input restricts the chance of a malicious payload being processed. So this is commonly paired with some automated tools to improve the security measures. And next one, like input validating should be implemented across all the user input to retrain the loopholes such as those specified on some hidden fields, query parameterization, and API request. And robust input validation also lightens the load on some additional security layers. Okay, so these are the deduction mechanisms where it is commonly used. Okay, and there are some type of code injection like SQL injection. So SQL injection is where an attacker inserts a code in SQL query so that the command controls the database. So these kind of SQL injection can lead to bypass for authentication or the attackers getting access to some sensitive data and can also modify or delete the entire databases. So attackers can create some structured SQL statements that ride on top of the legitimate queries. A single vulnerable query can expose an entire data infrastructure to the attackers. For example, like uh, select star from users where the username is equal to username and password is equal to password. Okay, so username he may be fitting, but instead of password, he will giving some malicious input so that no one can able to try to access that folder or whatever the situation. And command injection. So this attack targets the application that uses input from the user to the system level commands. And this type of attack can be catastrophic since it runs with the same permission as the application server itself. And using some command injection, attackers can read the system files, install the malware, or pivot to some other systems into the network. He can give some malicious input, like IP address he can able to change, right? Like another cat command, if you're just discussing, it will be generating the malicious input. Okay, so that is one thing. And next one, cross-site scripting, that is XSS. So cross-site scripting is an attack in which unwanted scripts get injected into some trusted websites that end up executing scripts in some visiting browsers. So unlike other types of injection targeting resources on the server side, XSS exploits the user's trust in a genuine website. Okay, so this, if you are giving some malicious input like attacker.com, yeah, something like different websites also you can give. And LDAP injection. So LDAP injection affects application that communicate with some directory services, and this is very alarming for some enterprise applications where LDAP is used heavily for user authentication and authorization. Like malicious input, he is giving like username is equal to star and UID like star in the sense, so that will be injected. Okay, so that these are some of the injection methods available. Okay, and next topic we're gonna discuss is that how to prevent these kind of code injection attack. So this is a very good question, right? So how to prevent this kind of attack? Okay. So first of all, by using some input sanitization. Second one, parameterized queries. Third one, like output encoding. And fourth one, that is content security policies. Okay. So to avoid these kind of code injection, you have to adapt these kind of code practices like mentioned. So to reduce the risk of injection vulnerabilities, organizations should implement best practices throughout the software development lifecycle. Okay. The first one is that input sanitization. This practice prevents the malicious inputs by filtering out dangerous characters from all the user input before it is processed. And the developers can neutralize potential attack vectors such as SQL commands or script injections simply by stripping some unwanted characters or patterns. So these steps make sure only safe and expected values reach the backend systems. And to implement the input sanitization properly, The developers need to ensure that they identify all the potential inputs, query parameters, cookies, and HTTP headers and sanitize them as they go. And it is the first line of defense when there is some other security measures. And second one is parameterized queries. So preparing statements is also referred to as parameterized queries are used to secure the interaction with the database by delimiting the user input from some query logic or parameterized queries are different from the traditional query technique, right? In which there is a direct concatenation of input and the raw query. So in the parameterized query also, the input is treated as a data. Uh, and it's not executable. So thus avoiding some SQL injection attacks. So parameterized query, for instance, use the placeholders as specifier instead of actual data when writing a query, such as select star from users where the name is equal to input. And the database securely binds user input to those placeholders. It can help you avoid the injection by using the dynamic queries. And next one, output encoding. So output encoding is a context-sensitive encoding that encodes users' content such that the malicious code is not executed as a species of small scripts executed in the browser. For example, special characters such as greater than less than symbol are converted to the encoded events like ampersand LT semicolon and ampersand GT semicolon. Okay, so ensuring they are treated as text instead of executable code. Okay, and this technique is very useful in some preventing access as attacks, so as we have seen, and using some output encoding frameworks such as OWASPs and ESAPI, or even built-in libraries within the modern programming languages, which can help significantly to reduce this risk. Okay, and last one, content security policies. So content security policies is a security mechanism that is implemented in the browser that prevents the execution of unauthorized scripts on a web page. And this CSP helps to reduce the excess attacks by specifying a strict set of rules about how your website behaves, such as whether or not scripts can be included from untrusted sources. And this CSP is most effectively used in conjunction with good input sanitization and output encoding. So all these policies details are regularly updated to include some new dependency or changes in the application structure so that they remain effective. Okay. So in this particular video, we have discussed on the topic for detecting the code injection. So what is meant by code injection and what are the common code injection methods, right? And how to detect by using some tools and techniques we have seen discussed, and what are the advanced detection techniques, right? And how to prevent these kind of uh, methods and detection mechanisms. We have like static, dynamic analysis, runtime protection, input validation. How to prevent these kind of code injection attacks we have discussed. What are the types of code injection attacks we have discussed, right? So I hope this video will be very useful for you. We will see you in the next video. So thank you all.